In this lesson, we are going to go over the study guide for your test 1 that will cover sections 2.5, 9.1, 9.2, sorry about that, 9.3 and 9.4. Your test will consist of approximately 25 to 35 questions. You have a great deal of problems on this test. It's actually, or on this study guide, it's actually 9 pages. And it has a total number of 40 questions. The reason it has so many questions on there is so you get some more practice, or as much practice as you can for the test. So don't forget that you have homework due the day that your test is. So it's always due at the beginning of class. So make sure you have your homework, and even if you only have partial homework, partial credit is better than no credit at all. So we're going to start off with section 2.5, relations and functions, and the directions state to evaluate each function for the value specified. So they're asking us to evaluate f of 0, f of -1, and f of +1 into the function f of x equals x squared minus 3x plus 5. So we're going to do f of 0 first, which means we're going to plug in 0 in place of all of our x's. Okay, so always put your number in parentheses. The number that you're plugging in for the variable, make sure that you do put that in parentheses. So 0 squared, 0 times 0 is 0. -3 times 0 is 0. And then we bring down our 5. 0 plus 0 plus 5 is 5. Now we have f of -1. So I'm going to plug -1 in place of all of my x values. So -1 squared means -1 times -1, which is +1. -3 times -1 is a +3. Bring down your plus 5. So 1 plus 3 plus 5 is going to give us a 9. And now we'll plug in f of a +1. So that's 1 squared minus 3 times 1 plus 5. So so +1 squared is 1. -3 times 1 is -3. Bring down your 5. So 1 minus 3 is -2. And then -2 plus 5 is a +3. Moving on to problem number 2. For f of 0, I plug in 0 for all of my x's. So remember, your exponents come before your multiplication. So we bring down the -2 and we say 0 squared is 0 plus 0 minus 7. -2 times 0 is 0 plus 0 minus 7, which will give us a -7. Okay, so for f of 2, which is what they ask us for next, we have -2 times 2 squared plus 2 minus 7. So we do our exponents before we do our multiplication. So 2 squared is 4 plus 2 minus 7. So -2 times 4 is -8. -8 plus 2 is -6. And -6 minus 7, remember, keep, change opposite, that leaves us with a negative 13. Now we're going to evaluate f of negative 1. Oops. So we have our negative 2, and then our negative 1 squared, plus negative 1 minus 7. So the first thing we're going to do is our exponents. So negative 1 squared is 1. And I'm just bringing everything else down. Negative 2 times 1 is negative 2. Negative 2 plus negative 1 is negative 3. And then negative 3 minus 7. Keep, change, opposite, which gives me a negative 10. So in the next section, this is still section 2.5, but it's the next part of it. We have rewrite each equation as a function of x, use f of x notation to find the result. So remember, you have to get your equation in that y equals mx plus b form first, and then you replace y with f of x. So this is already in that y equals mx plus b form. So all I'm going to do is replace my y with f of x, bring everything else down. Okay, so on number 4, well, it's not in that y equals mx plus b form, so I need to get the y by itself, so I'm going to move that to x. So I do that by subtracting 2x from both sides, which gives me y equals negative 2x plus 1. So now to the next step, you replace your y with f of x. So your answer is f of x equals negative 2x plus 1. And remember, the negative 2x comes first because in your equation it says your mx is right next to the equal sign. So that's why we put it there. Okay. So on number 5, same instructions. So the first thing I'm going to do is subtract my 2x from both sides. So I get 3y equals negative 2x. Remember, your x comes first, minus 6. Then we divide by 3. And when we divide one term by 3, we divide all of the terms by 3. So y equals negative 2 over 3x. And then negative 6 divided by 3 is negative 2. So I have to replace my y with f of x. So I get f of x equals negative 2 over 3x minus 2. So moving on to section 9.1, evaluate each expression for the given value of the variable. So all they're asking us to do is plug in this 3 into all of the x's in our expression. So remember, when you plug in a number for a variable, you surround it with parentheses. So 2 times 3 gives us 6. 3 plus 5 is 8. But then we can simplify by dividing them both by 2, which gives us 3 over 4. Number 7. Plug that 18 in for x. So we get 18 divided by 9, which is 2. Make sure you do not put 2 over 1. If you do, that would be half off. So be careful that you only write your 2. So now, number 8, we're going to plug in a 2 for all of our x's. So we get 2 times 2, which is 4. Bring down your 5, and then 3 times 2 is 6. 4 plus 5 is 9. And then I can simplify by dividing each term, or in numerator and denominator, by 3 to get 3 over 2. Looking at problem number 9, we're going to plug a -1 in for all of our x values. So I'm going to simplify my numerator first. So 7 times -1 is -7. And then -7 minus 5 is -12. Then -1 minus 1 gives us a -2. So -12 divided by -2 is a +6. Again, do not put that as a +6 over 1. Moving on to page 3. The directions state for which values of the variable is each rational expression undefined. Okay, you guys did not like this section when I taught it. This video is being made in January of 2016. I don't care if this video is being watched in 2020. Y'all still do not like this section. So the directions are asking for what value of the variable, meaning what can you plug in to your variable to make your rational expression, which, remember, a rational expression means a fraction, and then undefined means your denominator is a 0. So they're asking what number can I plug into my fraction to make my denominator equal 0. So I want you guys to remember something that I taught you. Your numerators don't matter. So what I'm going to do is on every single problem, I'm going to black out the numerator so you guys can't see it. Because all it's going to do is confuse you. So all I'm wanting to know is what I can do to make these a 0. Now on number 10, 2. There's no way to change that 2 to a 0 because there's no variable to plug it into. So for that reason, we would put never undefined. You have to have the never in the answer because if you just say undefined, all you're telling me is that this is undefined. But it's not because it has a 2 there. So you would say never undefined, which means that there is no way we could ever change that to be a 0. So over here, what number can I plug into y to make it a 0? That's easy. The answer is 0. And we learned we can always set this equal to 0 if we want. Number 12, what can we plug in to that x to make this a 0? Well, I set it equal to 0 and you solve. If you did not already see that it was a +5, you now know by solving. Now, 3x minus 2 equals 0. You'll add 2 to both sides first. And then you have 3x equals 2. And then you'll divide both sides by 3 to get x equals 2/3. So those are the numbers you can plug into those denominators to make them set equal, or to make them equal 0. All right. Simplify each expression. Assume the denominators are not 0. So this is still section 9.1. So what I'm going to do is I'm going to look at my numbers and my numbers first. So between 18 and 24, they have a common number of 6. So I'm going to say 6 goes into 18 3 times, and 6 goes into 24 4 times. Remember, I taught you that if it helps you to black out what you have just crossed out, then that's perfectly fine if that helps you. So you now have 3x to the 5th over 4x to the 3rd. So we know we're not done because we have x's in the numerator and the denominator. So I know my 3 and 4 are going to stay the same. When you divide your bases, you subtract their exponents. So 5 minus 3 is 2, and it goes on top because that's where your bigger number is. So your answer is 3x squared over 4. On number 15, we have a positive number divided by a negative number. We know our answer is negative right off the bat. So then 15 and 5 will simplify to be a 3 and a 1. So we get 3m to the 3rd n over mn squared. So I'm going to go ahead and write in these exponents of 1. So that gives me m squared on top because 3 minus 1 is 2, and 3 was the larger number, and an n to the 1st on bottom because 2 minus 1 is 1, and that was where your bigger number was. You do not have to write that 1 if you don't want to. It's up to you. Okay. Moving on to problem number 16. So since we see that there's multiple terms here, we know that we might need to factor. So I'm going to go ahead and factor my numerator. And I'm going to pull out a 7 to give me y minus 7 over y minus, over y minus 7. So we notice that our y minus 7's can cancel, leaving us with an answer of 7. Do not leave it as 7 over 1. For 17, we're going to factor. We can pull out a 5, which leaves us with x minus 4. And then we factor x squared minus 16. That gives us x plus 4, x minus 4. So your x minus 4's will cancel, and you're left with 5 over x plus 4. For number 18, again, we're going to factor. We have x plus 3, x minus 3. That's our difference of squares. And then for our denominator, that's your AC method. So that would be x plus 5, x minus 3. So our x minus 3's will cancel, leaving us with x plus 3 over x plus 5. You can either leave the parentheses on those numbers if that makes you feel more comfortable, or you can not include them like I'm doing here. It's up to you. So 19, we are going to need to factor, but this is a little more difficult. So we have 3w squared plus 8w minus 35. So we're going to use our AC method. So A is 3, B is 8, C is negative 35. So we have a 3w on top of our wings. So negative 105 in the top of our x, and a positive 8 in the bottom of our x. So we need to find out what multiplies to give us 105 and adds to give us 8. So I see that 7 and 15 could subtract to give us an 8, and our 7 would be negative. So we have a negative 7 and a 15. They multiply to give me negative 105, and they add to give me an 8. So before I write my answer in my factored form, I have to simplify. So I'm left with 3w minus 7 and then w plus 5. For my next problem, I had 2w squared plus 13w plus 15. And my a is 2, b is 13, c is 15. 2w goes on top. A times c goes on top of my x. And 13, which is my b, goes in the bottom. So our factors of 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6. So the two numbers that multiply to give us 30 and add to give us 13 are going to be 3 and 10. Don't forget, if you can simplify, you need to do so. So that gives us a 2w plus 3 and a w plus 5. Now you can simplify. Your w plus 5s are going to cancel, leaving you with 3w minus 7 over 2w plus 3. Now let's look at 9.2. This is on multiplying and dividing rational expressions. It's a third section we learned. So we learned that we can simplify first and then we can multiply, or we can multiply first and then simplify. I prefer to simplify. So the largest number that these have in common is 12. 12 goes into 24 2 times. 12 goes into 36 3 times. So I get 2x to the 7 over 3x to the 4. And then when you simplify your x's, you're left with 2x to the 3rd over 3. When you divide your x's, you subtract your exponents, and the answer went up top because 7 was larger than 4. Now let's look at number 21. So this is division. So our rule for division is to keep that first fraction the same. Change your division to multiplication. And then you flip that second fraction. You cannot simplify until you have changed it to multiplication. So our 4 and 12 will simplify to be a 1 and a 3. And remember, I don't recommend simplifying your variables until after you've combined your two fractions. So that gives me 3a to the 4b squared. And I got that because this a has an understood 1 there. So 3 plus 1 gives us that 4 over a squared b to the 3rd. And again, it's because all of these that don't have exponents have understood 1s there. Now, to simplify, my 3 is going to stay up top, and then I have a squared, 4 minus 2 is 2, and then b to the 1st, which goes on bottom because 3 was larger than 2. Now looking at problem number 22, since we have multiple terms, that lets us know we're going to need to factor. So I'm going to go ahead and write my new lines, and I can factor a 6 out of my first numerator, which is going to give me y minus 3. 9y is in our denominator, 10 is up here, and then I'm going to take a 5 out here to be y minus 3. So our y minus 3's cancel, and I'm going to black this out a little more just so it's easier for us to see what's left over, because it's about to get a little messier. Then we see that either the 6 and the 9 No, both the 6 and the 9 and the 5 and the 10 are going to simplify. Sorry about that. So what I'm going to do is simplify my 6 and 9 to be a 2 and 3. So I'm going to black those out as well, just so we can see what we have left, because it gets real easy to forget something. And then my 5 and 10 will simplify to be a 1 and 2. I'm going to black those out as well. So that gives me 2 times 2, which is 4, 3 times y, which is 3y. What a lot of people will do is forget that y is even there, so that's why we blacked out a lot of it. Okay? So now, in number 23, I'm going to set up my new lines. I'm going to factor what I can. So here I can factor out an m, which leaves me with m minus 3. Here I can factor out to be an m minus 2, m minus 3. If you did not get m minus 2 and m minus 3, you did something wrong, so make sure you check yourself. M squared minus 4 simplifies or factors to be an m plus 2, m minus 2. And then when you factor this trinomial, you get m minus 2, m minus 5. So now let's go ahead and find out what simplifies. So you have an m minus 3 and an m minus 3. Again, I'm going to black out so we don't forget anything. Then we have an m minus 2, and that will simplify with either one of these m minus 2's. It doesn't matter there. So we're left with m plus 2 over m minus 2, m minus 5. These cannot cancel because those signs are different. All right, moving on to number 24. This is division, so before I factor, I'm going to keep that first fraction the same. I'm going to change the division to multiplication, and then I'm going to flip that second fraction. So now I'm going to factor what can be factored. That 2a squared isn't going to be able to factor, so I'm just going to rewrite that. 3a plus 6, I can pull out a 3, and it leaves me with an a plus 2. A squared minus 4 would be, oops, that would give me an a plus 2, a minus 2, that's my difference of squares, and then a squared minus 2a. You pull out an a, and you're left with a minus 2. So now we are going to simplify what we can. These a minus 2's will cancel. These a plus 2's will cancel. So that leaves me with 3a over 2a squared. Those a's can still simplify, which leaves you with a 3 over 2a. Moving on to page 6 of your study guide. It's the last problem on 9.2, and it's already multiplication, so I'm going to go ahead and factor. So I get x minus 3, x plus 1 when I factor my trinomial, x minus 2, x plus 1, x squared minus 4 is x plus 2, x minus 2, and then here we have x minus 3, x minus 5. So now we can cancel We have an x minus 3 here and an x minus 3 here. We have an x plus 1 and an x plus 1. And we have an x minus 2 and an x minus 2. So we're left with x plus 2 over x minus 5. Now moving on to section 9.3 over adding and subtracting rational expressions. So remember, rational expressions, they're telling us that we're going to be working with fractions, so we're going to be adding and subtracting fractions. Perform the indicated operations and simplify your results. So remember, the golden rule for adding and subtracting fractions is that you have to have a common denominator. Notice here on number 26 through 28, all of them are common denominators, so that's good. So we can go ahead and combine our numerators. I'm going to put these in parentheses to get us into a good habit, because it won't really change our answer in number 26 because it's addition. However, when we get to 27 and 28 where there's subtraction, it will make a huge difference. So remember, we have to ask ourselves 2 questions before we can release anything from those parentheses. First, can I combine these like terms? They are not like, so no. Second, is there anything multiplying out in front? The answer is no. So I'm left with y plus 4. That can be released from the parentheses. And then, can I combine these 2 terms? No. Is there anything multiplying out in front? No. So I'm left with y plus 10. And you keep your denominator of y plus 7. Now we combine all of our terms that are like. So y plus y is 2y, and then 4 plus 10 is 14 over y plus 7. Now we factor to get 2 times y plus 7 over y plus 7. Those cancel to leave you with an answer of 2. Make sure you do not leave it as 2 over 1. So for number 27, I have a common denominator, so I can go ahead and write everything over that same denominator. But since that 3x plus 4, it has 2 terms over the same denominator, I'm going to put it in parentheses. Oops, sorry about that, guys. Okay, so now I have to release this from that set of parentheses. So I have to say, are these 2 terms, can they be combined? The answer is no. Is there anything multiplying out in front? The answer is yes, because it's a -1. So you have to distribute. So that gives us 4x. -1 times 3x is -3x. -1 times 4 is -4. Over our denominator of x plus 1. Then I combine my terms that are like. So 4x minus 3x is x. Bring over your minus 4 over x plus 1. Nothing can simplify. Please do not say these x's simplify, because they are being added or subtracted to another term. That's why you cannot simplify those x's. You can only simplify them if they are being multiplied. So now on number 28, we can go ahead and combine your numerators because they have the same denominator. But remember, you have to use those parentheses or else we're going to get some things wrong. So I can't combine these 2 terms and nothing's multiplying out in front. So I can go ahead and write 5x plus 7 and release it from those parentheses. Then my 2x minus 5, I can't combine those terms, but there is a -1 multiplying out in front. so I am going to have to distribute that. So negative 1 times 2x is negative 2x. Negative 1 times negative 5 is 5. And that's all over x plus 4. Now I combine my like terms to give me a 3x plus 12 over x plus 4. I can factor my numerator. When I pull out a 3, I'm left with x plus 4 over x plus 4. Your x plus 4's cancel, leaving you with an answer of 3. Now let's move on to page 7. We have a lot of practice on section 9.3 because that does seem to be the most difficult for students. So there's plenty of practice here. So notice on the rest of these problems we do not have a common denominator. So we have to get one. So between 6 and 4, our common denominator is going to be 12. And between x squared and x, we're going to use x squared. You're always going to use whichever variable has the highest exponent. So, to get 6x squared to be a 12x squared, you multiply by 2. Remember, what you do to the bottom, you do to the top. So 2 times 5 is going to give us a 10 up here. And then 4x to get 12x squared. We know we're going to multiply by a 3, and we need to multiply by an x, because if we just have 1 here, we need 1 more to get an x squared. Okay, so 3x times 3 is going to give us a 9x. Now when we add those together, we get 10 plus 9x over 12x squared. And then we want to write it in descending order. And nothing factors and nothing simplifies. You can't simplify the 9 with the 12 or the 10 with the 12 because they're being added. Okay, so you cannot simplify any of these. So you're left with 9x plus 10 over 12x squared. So number 30, remember when in doubt, you can always multiply your denominators together to get a common denominator. So our common denominator is x and x minus 5. So this denominator is missing an x. So x times 2 is 2x. And this denominator is missing an x minus 5. So we're left with 1 times x minus 5, which is just x minus 5. Now we can put everything over the same denominator. So we get 2x, and remember, whenever you have more than one term in your numerator, you're always going to put it in parentheses when you rewrite it. Also, remember, you cannot simplify until after you've combined your entire numerator. Because you're subtracting that x minus 5 is why you can't simplify right away. So, to release that from the parentheses, I say, can I combine these two terms? The answer is no. Is there anything multiplying out in front? The answer is yes. It's an understood negative 1. So we're going to distribute. So we have 2x. Negative 1 times x is negative x. Negative 1 times negative 5 is 5. Leave your denominator of x times x minus 5. Then we combine our like terms. 2x minus x is x. Bring over your plus 5. And then you have x times x minus 5. You cannot simplify anything because this x and this 5 are being added to each other. So your answer is x plus 5 over x times x minus 5. Now on number 31, our common denominator is going to be y plus 5, y plus 4, okay? So for the y plus 5, we need to multiply by y plus 4, and for the y plus 4, we're going to multiply by y plus 5. And I apologize if that slamming of the doors, if you guys can hear that, I apologize. My office is right next to the exit to the building, so people are constantly walking in and out, so I apologize about that. So on my first fraction, I have 2 times y plus 4, and on my second fraction, I have 3 times y plus 5. So now that I have a common denominator, I'm going to rewrite everything over the same denominator. So that gives me 2 times y plus 4 plus 3 times y plus 5 all over the common denominator of y plus 5, y plus 4. You cannot simplify anything until you combine your entire numerator. So first we're going to have to distribute, which gives us 2y plus 8 plus 3y plus 15 over y plus 5, y plus 4. 2y plus 3y is 5y. 8 plus 15 is 23 over y plus 5, y plus 4. 5y and 23 don't have any common factors. 23 is a prime number, so that means that we are finished. There's no way this can be simplified. Okay, now look at problem number 32. Problem number 32 is a little more difficult only because we haven't really done a problem like this yet. So the first thing we're going to have to do is factor each of our denominators. So in the first denominator, notice you have a 3 in common. So we can pull out a 3 that gives us an m plus 1. And then over here we can pull out a 2, which gives us also an m plus 1. So notice that we have something that looks a little more similar between the two denominators now. So m plus 1, we know that that has to be in our denominator. So then you only have to worry about that 3 and that 2. Well, if we just had denominators of 3 and 2, we know we would have a common denominator of 6. Okay? And if this is messing you up, then you can completely black this out so you can't see it anymore. Okay? So now, to get a common denominator, well, from 3 to 6, we would need to multiply by 2, and then we have the m plus 1 in common. So our new number here would be 12 because 2 times 6 is 12. And then here, between a 2 and a 6, you would want to multiply by 3, and you already have the m plus 1 in common, so our new number here would be 15. So now we're going to combine those numerators. 12 minus 15 is negative 3 over 6 times m plus 1. And then the 6 and negative 3 can simplify to give us negative 1 over 2 times m plus 1. Okay. So now, let's look at page 8. So again, let's factor that denominator first, okay? X plus 3 doesn't factor, but x squared minus 3x does. We could pull an x out to give us x minus 3 left over. Okay? So we know x minus 3 has to be in our common denominator, but we also have to incorporate that x. So our common denominator is going to be x times x minus 3. So in your first fraction, we're missing an x. So what we do to the bottom, we do to the top. So our new numerator is going to be 7x. Then, if we have an x times x minus 3 and x times x minus 3, we already have a common denominator. So we don't have to change anything here. We're just going to bring that 5 over. So now we're going to combine everything to be over the same denominator. Nothing simplifies. This x does not simplify with either one of these because it's being subtracted by 5. So this is our final answer. Okay? For number 34, we're going to factor what we can in our denominators. So this denominator is going to factor out to be a minus 4, a minus 5. Okay? So our common denominator is going to include an a minus 4. And it also has to incorporate that a minus 5. So for this first fraction, it has the a minus 4 and the a minus 5 that we need. So we're just going to carry over that 2a. Then my a minus 4, all it's missing is the a minus 5. So what we're going to write here is 8 times a minus 5. So now we write everything over the same denominator. Remember, you cannot simplify just yet. You have to combine your entire numerator first. So you get 2a plus. Distribute your 8 to get 8a minus 40 over a minus 4, a minus 5. Combine your like terms. To get a minus 4 and a minus 5 on the bottom and 10a minus 40 on top. Now we can factor out a 10 to give us a minus 4 and then a minus 4 and a minus 5. Our a minus 4's cancel, which leaves us with 10 over a minus 5. Okay? So for number 35, we're going to factor out that denominator to be c plus 2 and c minus 1. So we know our new denominators are going to incorporate a c minus 1 and a c plus 2. So in our first fraction here, you have the c minus 1, but you're missing the c plus 2. So we're going to multiply that by that numerator to get 2 times c plus 2. And then we already have the common denominator we want here, so we're just going to bring that 6c over. So now I'm going to write everything over that same denominator. You cannot simplify just yet. You have to combine your entire numerator first. So we're going to distribute that 2 to give us 2c plus 4. Bring over your minus 6c over c minus 1, c plus 2. Combine your like terms to give you negative 4c plus 4 over c minus 1, c plus 2. And then you can factor out a negative 4. The reason you do that is because you never want this first term to be negative, and they have a 4 in common. So that leaves you with a c minus 1. If you're confused as to why it's a minus 1, remember when you take out a negative 4, you divide each of these terms by a negative 4. And so 4 divided by negative 4 would give us a negative 1. So your c minus 1s are going to cancel, leaving you with negative 4 over c plus 2. Now, let's look at number 36. Now with number 36, if I gave you a problem like this, it would definitely be more of a bonus. Okay, so just so you guys know that. Okay, so first thing I'm going to do is I'm going to factor out my denominators. Okay, so that's an x plus 3. Actually, you know what, guys? I'm actually going to do this on a separate sheet of paper. Otherwise, I think that y'all are going to go insane trying to look at my small handwriting to fit it. So I'm going to rewrite this. Just one moment, please. Okay. So the first thing I'm going to do is factor out my denominators. So this is a difference of squares. So it's x plus 3, x minus 3. And then here, it's an AC method, x minus 1, x minus 3. Okay? So now, to get that common denominator, I know I'm going to have to incorporate an x plus 3. I'm going to put a check mark to say we've already included that. I know I'm going to have to include an x minus 3. And I'm going to have to include an x minus 1. Okay, so that hot mess is our common denominator, but please do not fast forward just yet because this problem is not as difficult as it looks like it's going to be. So bear with me. So here, I have an x plus 3 and an x minus 3. I'm missing the x minus 1. So I'm going to multiply that 4 by x minus 1. So I'm going to rewrite it. This one has an x minus 1, it has an x minus 3, but it's missing that x plus 3. Okay, oops, forgot to write my x minus 1 down here. So it's missing the x plus 3. So I'm going to rewrite that 3 times x plus 3 here. Now I write everything over the same denominator. Okay, You cannot simplify yet because you have to combine your entire numerator first. So I'm going to distribute. So that's going to give me, oops, sorry about that. That's going to give me 4x minus 4 minus 3x plus 9 over x plus 3, x minus 3, and x minus 1. Then we're going to combine those like terms. Gives us x, because 4x minus 3x is x, and the negative 4 plus 9 is a positive 5 over x plus 3, x minus 3, x minus 1. That is our final answer because nothing will simplify. So that was not as scary as it looked. Okay, so just in case I did not include the entire view of the whole problem, there it is for you. Okay, that's the entire problem for number 36. So I'm going to go ahead and just write the answer we found over here. And when copying problems from scratch work onto your paper, just make sure you do not rewrite it incorrectly. Okay, moving on to the final page of our study guide. We have our complex fractions. So this is written a little smaller, so I'm actually going to zoom in a little bit so it's easier for you to see those small numbers. I hope that's helped. So remember, complex fractions are a fraction within another fraction. So I taught you to circle your top fraction, circle your bottom fraction, and then write it horizontally. So now, since we've already written it as division, you keep the first fraction, you change it to multiplication, and then you flip the second fraction. So our 15 and our 10 are going to simplify to be a 3 and a 2. So that gives us 2x to the third over 3x to the fifth. And then our x's simplify to be an x squared on bottom. Okay, so our answer is 2 divided by 3x squared. Number 38. Circle your top fraction and circle your bottom fraction. So I'm going to rewrite it horizontally. So I'm going to keep that first fraction the same, change it to multiplication, and I'm going to flip it. Now I'm going to factor what I can. So y minus 1 doesn't factor, but y squared minus 4 does. It gives us a y plus 2, y minus 2, y squared minus y minus 2 factors to give you a y minus 2, y plus 1, and then y squared minus 1 factors to give you a y plus 1, a y minus 1. So now simplify what you can. Your y minus 1 and your y minus 1 cancel. Your y plus 1 and your y plus 1 cancel. And your y minus 2 and y minus 2, they cancel. Notice you have nothing else in your numerator, but you have a y plus 2 in the denominator. Do not say your answer is y plus 2. Your answer is 1 over y plus 2. You cannot just leave that numerator blank. You have to put something there, so that something is always going to be a 1 if it's blank. Okay? So now on number 39, I'm actually going to do this one on a separate sheet of paper just because this is such small handwriting, or such small type, it's really hard to see. So that gives us 1 plus a over b over 1 minus a over b. And I'm actually going to zoom back out now since I'm doing that. Okay. So, first thing we are going to do is put our whole numbers over 1. And I taught you in class that it could be helpful if you covered up your bottom fraction first. So we're going to need to combine these two fractions in order to get a one single fraction. So we're going to multiply this side by the b's. Okay? Common denominator between 1 and b is going to be b. So I get b plus a over b. And then for my denominators, my common denominator is a b, so I multiply this side by b's, which gives me b minus a over b. So now you circle your top fraction and your bottom fraction. You write them horizontally. And then you keep change flip. So these b's are going to cancel, and you're left with b plus a over b minus a. And the only other thing you can do to simplify this would be to write your problem correctly, which would be in alphabetical order. So the a should come before the b. So one is a negative a plus b. So technically this one is the answer, but I would have accepted that one as well. So that was problem number 39. So I'm going to put the correct answer on there, which is a plus b over negative a plus b. And then we're going to work problem number 40, which number 40 has 2 minus x over y divided by 4 minus x squared over y squared. First thing I'm going to do is I'm going to put these whole numbers over 1. And remember, it's always easier if you just cover up that bottom fraction. My common denominator here is going to be a y. So I'm left with 2y minus x over y. And then here, my common denominator is y squared. So I'm left with 4y squared minus x squared over y squared. So you circle your numerator and then your denominator, your top fraction and your bottom fraction, and then we're going to write them horizontally. So 2y minus x over y divided by 4y squared minus x squared over y squared. So you keep change flip. So 2y minus x over y times y squared over 4y squared minus x squared. So now I can factor. It might be a little hard for you to see, but this denominator is actually a difference of squares. So that's 2y minus x over y times y squared over. This factors to be 2y plus x and 2y minus x. So your 2y minus x cancel. And notice these y's here. They'll simplify as well. So when that happens, you're left with just a y in the numerator and then 2y plus x in the denominator. So the only other thing you can do is write them alphabetically. So you would have a y still in the numerator, your x would come first, and then you would have 2y. So your answer for problem number 40 is going to be y over x plus 2y. So that concludes your Test 1 study guide. I hope that you have found this helpful. Remember that if you can complete my study guide successfully and you can get all the answers or a lot of the answers correct, then you are ready for my test and you'll be successful. So I wish you the best of luck.